So we're doing the Having a Ball lab, and I thought I would just work out the first problem with you. You guys help me out, you guys that are here with a calculator, okay? Because I don't have a calculator up here with me. So we've got a softball player. She throws a ball straight up as hard as she can and then catches it. A friend with a stopwatch measures the time between the release of the ball and the catch. If the time measured is 4.8 seconds, how high did the ball go and how fast was the ball traveling just before it was caught? Okay, and, oh dear. Let's put a question mark on there. All right, so let's do it. So you don't have to copy the problem down, just use given, find, and solve as I'm about to do. So number one, given. No whistling, please. God, I'm trying to record this and people are whistling. I think it was Ikra who was whistling, so if you know Ikra, you can blame her. All right, so let's just imagine the ball's right here, and it's thrown straight up with a certain initial velocity, but that's not given. And it goes up, and it comes down like this. And let's say it's at the same height when it's caught, and we want to know this is the velocity just before it's caught. So this V naught is the velocity of the ball after it's left the hand of the thrower. So it's going the maximum velocity it's going to go because gravity is going to slow it down. What do we know is true about the velocity of the ball at the very top? Well, try this. Take a ball, throw it straight up, and then look at the very top. It stops. Now, it doesn't stay stopped. That would be a neat trick, right? You throw something straight up, and then it just sits there. No, it only is stopped for an instant in time, and then it comes. Gravity starts pulling it right back down, accelerating it, speeding up all the way until just before it's caught. And it's going to turn out that these velocities are exactly the same if we neglect air friction, and which we are going to do. What do we know? We know that the time that it took to catch the ball was 4.8 seconds. Now, it's not stated in the problem, but we know something else. What is the acceleration of gravity? 9.8 meters per second every second. And in what direction? Well, things tend to fall down, and we make down the negative direction. Okay? What are we trying to find? Well, we are trying to find, let's make it a part A and B. How high did the ball go? So I'm going to call that delta y max. That's the maximum delta y. That's how high it went. Max. And then for part B, we'll break it up into two parts. We'll say, what is the final velocity v? Right here. And don't get confused. I've got two final velocities, but those are happening at two different times. So there are multiple ways to go about this problem. Maybe I'll show you both ways, but there's actually a lot to go over with this problem. Let's solve it. Well, if we look at the whole problem, goes up, comes back down, what's delta y? Well, here's my initial height. Here's my final height. It's the same. But anyway, I can say, well, delta y equals v naught t plus 1/2 a t squared. Now, why did I pick this one? Well, I don't know what v naught is, and you always need to know what v naught is. So somehow we have to figure out what it is. And this has v naught in it, but we know what delta y is for the whole thing. It's caught at the same height it was thrown, so delta y is 0. And so I can write this 0 equals v naught t plus 1/2 a t squared. And now I want to solve for v naught. So I can subtract this term to the other side, or actually I can flip flip them around. So V naught t is equal to negative 1/2 a t squared, right? All I did was subtract this to the other side and then flip it around. Does everybody follow that algebraic step? But I want to get V naught all by itself. So what do? I divide both sides by t. And so now I get V naught is equal to negative 1/2 a t, right? Because the t cancels with the t squared. Trust algebra, okay? Algebra works. And it's kind of amazing that it does. We live in a mathematical universe. Negative 1/2, well, what is the acceleration? Negative 9.8 meters per second every second. And then times time, how much total time? 4.8 seconds. Notice that the seconds, we'll cancel the seconds here, leaving meters per second. That's good. The negative cancels the negative. And so, what do I get? What is 1/2 times 9.8 times 4.8? 23.52? Okay. Well. Meters per second. And obviously it's in upward direction. Okay, so we can use that. That's not my final answer. But let's do part A. Let's figure out how high this thing went. So let's go back over here. Yes. You know what? I'll try to zoom out so you can see it. All right. The negative. Okay, the 1/2 is in the. Okay, the question was where did the negative 1/2 come from? It came from the algebra. Now look at the first step. Second step, delta y is 0. Now I'm going to solve for V naught. I have to subtract this to the other side, and that's where that negative sign comes from. Minus 1/2 at squared equals V naught t. And then I divided by t to get V naught all by itself. And now this negative will cancel with that, giving a positive upward velocity, right? Positive means upward, so we want our initial velocity to be up. So we're good. Okay, is everybody with me? So we can now solve for delta y, because what do I know? I know the initial velocity. I know the final velocity. Now, I do kind of know the time. I know it's 2.4, but I haven't done anything to prove that really. So we can use the equation that doesn't have time in it. So let's say v squared equals v naught squared plus 2a delta y. Well, now my final velocity is up here. And I know what that is at the very top. What is it? It's 0. And I know what v naught is because I had to solve for it. So now I can solve for delta y. Now I'm going to do this in one algebraic step because I'm good at algebra. If you want to break it down, just do it in more steps. Subtract this to the other side. Divide by 2 times the acceleration. Now we can plug in our numbers. Negative 23.52 meters per second squared. Now notice that the parentheses are here. This negative is outside that parentheses. We're going to need that negative because the acceleration is negative 9.8 meters per second squared. Now here's what I need. So the negative goes away. So here's my answer for delta y. I need someone to do the math for me. What is 23.52 squared divided by 2 and then divided by 9.8? 28.24? 28.224? How about 28.2? We'll just round it off. Does everybody agree with that? I'd like more than one. I'd like that to be confirmed. Yeah, is that what you got? Okay. Thank you. Sorry for doubting you, Ryan, but you know, one has to check one's work. Okay, so now we're ready to solve for the final velocity down here. And I'm going to, again, use the fourth kinematic equation to do it because it's easier to do that way. There's multiple ways to do this problem, by the way. There's lots and lots of ways. V squared equals V naught squared plus 2a delta y. But now we're doing it for the whole thing. Well, what is delta y for the whole thing? It is 0. So this whole term, 2 times a times delta y, this whole thing is 0. And so now we can solve for v. So v is equal to the square root of v naught squared. What is the square root of something squared? Itself, sort of. So let's, yeah, there you go. Who said that? Nicely done. Nicely done. Okay. That was Connor O'Keefe who came up with that. It's plus or minus. It's ambiguous. When you take the square root of something squared, you have to have the plus or minus. And so what is V naught? V naught was 23.52 meters per second. Now look, let's look at the problem. The answer for my final velocity could be 23.52 meters per second, or it could be negative 23.52 meters per second. Which one do you think it is?
Negative.
Why? Yeah, it's negative. Why?
Because it's going down.
Because it's going down, yes.
That was Moroni.
That was Moroni who came up with that? Good job, Moroni. All right. You're now immortalized on YouTube. You can go listen. You can have your parents listen to this. Ryan, I've already mentioned you, so. All right, so there you go. That now we're done with this problem. But I want to show you something else. There's an easier way to do it. There's multiple ways to do this problem. All right, and this is a good way to do it. But one of the things you could do is say, look, well, first of all, is everybody done with this? Who? Okay. All right. Now, if we look back on this, and let's do another solve, it can be a little bit easier if you just say, oh, let's just assume that the time it takes to go from here to here is half the time. And let's just assume that the time it takes to go, from the top to the bottom will work. So I'm going to say V equals V naught plus A times T. Okay, do you all agree with that? That's the first kinematic equation. But let's start the problem when it's at the very top. So if we're starting the problem here, instead of V equals 0, this is V naught equals 0, right? If we're starting at the very top, we can just say, oh, let's call this V naught. Our starting velocity is 0. So I can say V is equal to A times T. Well, what is A? Negative 9.8 meters per second squared. And what is the time it takes to go from here to here? Well, if the total time is 4.8, what is the time from the top to the bottom? 2.4. I'm sorry, 2.4 seconds. What am I doing? Now, somebody tell me, what is negative 9.8 meters per second squared times 2.4 seconds? Negative 20 what? 23.5 meters per second. Does that match what I got before? Yeah, 23.5. Oh, guess what? I forgot to put the negative on here. Yeah, negative 20. Look, I got the same answer. Yay, clapping. All right. Of course, this was part B. Part B. Oops. And now let's do part A again, using time instead of the fourth kinematic equation. Now, what do I know? Well, I can figure out, I can say delta y is equal to v naught t plus 1/2 a t squared. But let's again look at the second half of the problem. Okay, from here down to here. So that means v naught is equal to 0. Shh. So this is 1. So this goes away. And this is going to be negative 9.8 meters per second squared times time squared. But what time do we use? If I'm going from here to here, 2.4, and I got to square it. Now somebody with a calculator right now, give me the answer for this. 1/2 times negative 9.8 times 2.4 squared.
28.2.
Should be negative 28.2, right?
Yeah, negative.
Because we got this negative right there. Now what does this delta y mean? Why is it negative? Because I'm looking at it from it falling down, and it fell down 28.2 meters. But if it fell down 28.2 meters, what did it do? It went up 28.2 meters, so I could say that delta y max, the maximum height, was 28.2 meters up. Now, which way was easier? This way with time, or this way, not using time? Yeah. I don't know. This way is a little bit harder. Not much, though. It's really the same thing. But it's kind of cool. To me, I think it's kind of cool that you can do the problem in multiple ways. This is using, I used the total time here to figure out the initial velocity, and then I used the fourth kinematic equation to figure out delta y and the final velocity. Here, a little more straightforward. If I know that time can be cut in half and I just look at the second half of the problem, I can do it that way. It's a little bit simpler. Okay, well, that's problem number 1, beaten to death. Okay, hope you enjoyed it. Hope you enjoyed listening as much as I enjoyed teaching it. Actually, I hope you enjoyed it even more. All right.